How did the best machine learning practitioners get involved in the field? What challenges have they faced? What has helped them flourish? Let's ask them. Welcome to Learning from Machine Learning. I'm your host, Seth Levine. Welcome to Learning from Machine Learning. On this episode, I have the pleasure of having Vincent Warmerdam. He's currently a machine learning engineer at Explosion, the company behind SpaCy and Prodigy. Vincent is an educator, a blogger, consistent PyData speaker. He's created many valuable open source tools. He's endorsed for awesomeness on LinkedIn over 100 times, and truly an inspiring force in the data science community. Welcome to the podcast.
Hi, that comment is making me check. Do I have 100 endorsements? I didn't know that.
Over.
Oh, okay, cool. Yeah, okay, cool. It's like an inside joke I had with a former colleague, like whoever can get the most. But yeah, I've got more than 99 endorsements for awesomeness on LinkedIn now. Nice. Okay.
Why don't you give us some background on your career journey? How did you get to where you are today?
I mean, it is, for me, it's a little bit hard to give proper career advice because I want to just recognize I'm a little bit privileged and I got lucky a whole bunch. Because, when I started this whole data science thing, this was the era when random forests were kind of new. And if you could just use a random forest, you're already way better than all the econometricians with linear models. So, can you run fit predict? Bang, you've got a job. I was kind of in that era at the right time. After that, though, I kind of started blogging. I started helping out, arranging some meetups. There's a machine learning meetup in Amsterdam I helped organize. There's the PyData Amsterdam one that I helped organize. And I had a pretty popular blog as well, so people started recognizing me for that. At some point, that recognition gets you places. You get invited to speak, and then people sort of see you as an authority figure. I'm not. I think I have sensible ideas. I like to think, but I try to be kind of modest about that. But that has been kind of the story of the career, though, because people knew my blog, which would usually include the CTO of a company, and then the CTO would say, "Hey, I like your blog. Can we just have a beer?" And then usually that led to the job offer. I have yet to talk to a recruiter. Honestly, I've never been hired through the recruitment pipeline so far in my career. It's always been via the CEO or CTO because they knew of my work beforehand. And this is very weird advice. This is a very bad story because this is very hard to replicate for others because I just got very lucky when it comes to this. I do think having a blog and being able to get recognized is very useful, just very hard to replicate. But I also like to think that, some of the side projects that I did for open source definitely helped out. The Calmcode thing is something that people know me of these days. I do like to think the whole... there's a Japanese saying, I think, plant 1,000 flowers and some of them will be a lotus. I do kind of subscribe to that idea. But a lot of it comes down to luck and a bit of privilege as well. I just want to be honest about that. But being able to be recognizable has proven to be useful to me, I suppose.
Yeah, definitely. Everyone's, journey is unique. What are the roles that you've played at different companies? I know you've been a consultant at one point, you've been an advocator. You've had some interesting titles, right?
I mean, there was a phase at a previous company where they would really let you pick any name you could, and me and a couple of colleagues would think it funny to really see how far we could stretch it. So I called myself a Pokemon master because I thought that was kind of funny. My favorite title was senior person because at some point I was just one of the old guys at the company, so I just called myself that. But I guess as far as roles goes, I've been doing lots of training, so at some point you call yourself a trainer. Because you're doing consultancy, you have different roles within different teams, so I was a lead at some point as well. I was sort of also helping recruit people at companies for the specific data team, etc. Sometimes my role would be super temporary, sometimes it would be for 2 years or something like that. But usually it's been I was a person in a data team trying to get the team to become productive, doing whatever. Usually the things I like to think I'm pretty good at is keeping things very simple. I can get a lot of mileage from linear models, which tends to work quite nicely. And before that, it was I also had lots of different jobs in college, and I do like to think that kind of helped as well. Before, like, my background is in operations research, but before that, I actually studied design. And my evening job, I was a bartender at a comedy theater in the Netherlands, which, I do like to think that might have helped my presentation skills in a way. Just like having studied design for a while also makes me think differently about algorithms. And how just like operations research kind of makes me think about constraints a lot when I'm doing data science things. Like, I like to think that I have a somewhat diverse background, and it's that somewhat diverse background, I suppose, that makes it easy for me to do the stuff that I'm doing now. I guess it's the summary.
That makes sense. So diving into your academic background, what was it? So it was operations research and some design. That sounds pretty unique there.
Yeah, well, so I studied this. I studied industrial design engineering for a year, and then I found out it wasn't for me, so I had to switch majors. And then the bachelor's was econometrics and operations research, and the master's was operations research. I thought that it was the most interesting of the two, but also because that kind of had like a little gateway to computer science. So if I wanted to do the computer science courses, that'd be kind of an easy way for me to get the courses I wanted to take. But then, I was also rowing when I was in college and did a bit of partying, so I wasn't allowed to start my master's just yet. So I also had this 1 year where I just took whatever course interested me. I did a couple of courses in neuroscience, which was pretty interesting,
Awesome.
social psychology and biology and whatnot. Again, like I like to think that the diversification of knowledge has proven to be quite useful, but the official title for my academic background is operations research. So that's the mathematics behind optimizing systems. That's kind of the thing that you're taught there.
Very cool. What's like the quintessential or a canonical problem in operations research that people would try to
like a very textbook example, I suppose, but like in machine learning, you usually try to optimize towards something. Like you want to get the loss as low as possible or the accuracy as high as possible, and you've got algorithms for that. You typically take your data and the label you want to predict, and you come up with some sort of loss function. You try to get that as small as possible. And in operations research, you kind of do a very similar thing. It's just that in operations research, you typically aren't dealing with a machine learning algorithm, but you're dealing with, let's say, hey, we have stocks that we would like to invest in. And, by the way, that also introduces constraints. Because, yes, we want to get the highest return, but of course, we don't want to overshoot the budget. And we also have a risk preference. And those are like defined as hard mathematical constraints. And then if you want to optimize, it's kind of a different ball game, because if your algorithm ever exceeds the bounds of the constraint, then you're in sort of bad territory. So that I would argue that's like the main thing if you're doing operations research that you're taught. Like constraints really matter, and you want to deal with those in mathematically, proper ways. And that's like a different ball game. But that's the main thing that they're dealing with, just this constrained optimization. That's what they do.
Very cool. Sounds like you need a very strong math background. Probably some linear algebra in there too.
Lots of calculus and linear algebra. Although I will say, like, it depends a bit on what you do. Like when you do the master's degree, of course, you get the theoretical courses and you gotta, do the proofs. But the moment that you start doing your thesis, like I had a professor who basically said, "I know nothing about machine learning, Vincent, but you seem so eager. You do machine learning and just teach me how it works, because I've got no idea." And that was also just fine, which is great. Like the professor just let me do do what I wanted to do, and I was also able to teach myself that way. But if you really want to do like the proper operations research, and especially if you want to do a PhD, it is super math heavy. That's true. A little bit too heavy for my comfort, to be honest. I'm a little bit more on the applied side of things, but I still know people who ended up doing a PhD, and they are definitely the math-proof kind of people. They're kind of this cookbook of linear algebra kind of a person.
Right.
Yeah, that's definitely in the field, definitely.
What was it that attracted you to machine learning? What initially got you interested in it?
I mean, there's always something cool about making predictions, right? So there's something about that I thought was pretty interesting. I think the longer story, though, I do remember, like, a very close family member of mine got a wrong medical diagnosis, and I do remember thinking, like, oh man, and it was, everything. The wrong diagnosis was they told the person, you have a very bad disease, and the person didn't. And we found out just in time, thank God. But like, they might have done some really weird life decisions, like sell the house immediately and that kind of a thing, because of that decision. So that made me think, like, okay, there's definite consequences to making the wrong decisions. So anything that we can do to make better decisions is an interesting thing. And maybe there's something about this machine learning. The whole idea that you try to learn more from data by using a machine, there's something plausible about that. That seems very interesting. So that was kind of around the time that I did think, like, hey, yeah, let's see if these algorithms might be able to do something. And then the career prospects turned out to be amazing. So that was like another motivation to sort of go into that realm. But the initial spark, I suppose, was a wrong decision got made. That's how I started thinking, hey, maybe there are systems that we can improve here.
Very interesting. And we're going to dive into machine learning in a bit, but having the creator and maintainer of Calmcode, just such an unbelievable resource. No, nothing to laugh about. Calmcode is incredible. It's like in the top 2 or 3 things that I recommend to every new data scientist. The way that you break down really complex things into a nice, calm, and logical and rational way is it's extremely valuable. So can you talk a little bit about Calmcode and why'd you start it, and what is it? I guess give everyone a breakdown first.
So first of all, happy to hear it that you like Calmcode. I'm happy to hear that it helps. So basically, the story behind Calmcode was at some point I was looking at like educational content around data science, and I was an educator. I taught some of these courses, and I just started noticing there's just so much gunk. So just to give an example, like the number one tutorial, like I guess like 4 to 5 years ago, like the number one tutorial on how scikit-learn works, what happened with this data set called Load Boston, which is about Boston house prices. And, you know, there's so many tutorials use that data set, from like all the O'Reilly books to a lot of open source packages. But then you look at the data set, and it turns out that one of the variables that they're using to predict a house price is like skin color. Like there's this... I forgot like the exact name, but it was like something percentage of blacks in the town, like something kind of horrible. You don't want to put that in the predictive model. It's a really, really bad idea. Also, why is this data set in scikit-learn? Why are so many people using it? So that just led to a lot of frustration on my hand. And then I also noticed that like there are these enterprise courses that use Load Boston that charge $1,000 a day, and you do look at it and you kind of go, this is a mess. And then I figured, if I'm this frustrated, maybe I can get energy out by just putting this stuff out there for free. I knew that I was knowledgeable enough to be able to teach these kinds of topics because I've taught them before. But I've also noticed that a lot of this educational content seems to focus more on the creator and less about like just getting the idea across. So I figured it would be kind of like a fun little experiment. Like if I were to make a learning platform, how would I do it? And that's how Calmcode just got created. The idea is you just have like max 5-minute videos to explain a single topic, and the sequence of those can be a little course on pandas or can be a little course on whatever. And also what I like about doing the Calmcode thing is for every single topic I can say, is this a Calm like tool? Is it something that makes your day-to-day nicer? And if the answer is maybe not, then I just don't teach it. Which is also one of the reasons why I don't teach Spark, to be honest, because because installing it is just such a pain. And sometimes there's like easier ways of analyzing the data than resorting to like a very big data tool. So it's just a very opinionated learning environment that people seem to have really liked. I've gotten lots of very nice responses. Ever since the baby showed up, I have been doing way less. But it has been like very cool to see that just a little hobby project of mine without distractions, that's very calm, seems to be getting between 10 and 20,000 people a month. And, I get lots of personal... people buy me beers at conferences out of the blue. Like that kind of stuff is just pretty cool, I would say. Yeah.
Yeah, it's a great resource. Yeah, definitely paying it forward, creating a place for data scientists to go to learn anything. Random question: have you ever found yourself going back to an old Calmcode to refresh yourself on some of the skills?
Totally. Yeah. No, so like that's like another reason. So one thing that Calmcode has proven to be quite nicely for me is it's kind of like a snippets library, because I knew the course that I made, and I knew that I definitely mentioned this in that course, and I kind of need a config file. Where is it? Just like today, I was looking at my typer course because I needed like, oh, how do options work again? Like copy paste. So it's also like almost a snippet tool for myself at this point as well. Not the original intent, but it is something that seems to be happening. And it's also like I'm building search for Calmcode now as well, like kind of as a hobby project, and I'm like contemplating like, hey, maybe the main thing the search feature should do is just find the right snippets, which is kind of like an interesting search problem on its own. But yeah, totally. Like I need a reminder too. There's like 80 courses. I don't have all of them in my head, like all of the time. I still watch my own stuff in that sense. Yeah.
Yeah. So yeah, it's probably just like a good resource, for you that you can consume, and then became also something that, you know, so many other people can use. I'm trying to think my first usage of it. I think it was like kwargs, args, which is like one of the first ones on there. Yeah. And that one, yeah, I revisit it every so often.
Oh, nice.
Yeah, thank you.
I would love to do more, but the simple fact of the matter is, like, my life is a little bit different now because of the baby. So like, and there's so many ideas I have that I could do with Calmcode. It's just that the one thing I also kind of like about the project is I can not spend any effort on it, and the site will just still run. Right. So that's also kind of the calm design of it. I really like having a hobby project where it's impossible to break, and even if it breaks, it's like super easy to fix, and it's just a static website, so that makes it super easy.
If there were no time constraints or any resource constraints, what would you do to improve Calmcode?
I guess so. There's like a couple of courses particularly that I would love to do. Like one of them is just embeddings. I think that there seems to be like a couple of, you know, there's a little bit of hype around it, but also just you can make embeddings do different things, and there's reasons why they work, but they don't solve every problem, and just you know, I think I can do a fun course where you start with like letter embeddings, then you move on to word embeddings, then images, and then you also show how they can fail. Like I think that would be super cool. Sort of Bayesian MCMC stuff I think would be nice to have as well, just because you can make very articulate models, which I think is a trick not people are appreciative enough of. And then I would love to have like a new section on the site, which is all about like demos and benchmarks. And that's because I think it's very hard to do a benchmark wrong. Like all benchmarks are wrong, but some of them can be very insightful. And I think just celebrating that a bit more would also just be fun. And there's a couple of examples that I've got lined up, but I've no time to actually produce it. But things like, hey, what can you do to actually make numeric algorithms converge a bit quicker? Like, does standardization really help or not? And like, just exploring that a little bit could be just super fun, I think. So like stuff like that's in my mind, but I mean, there's always stuff to make. And like another thing I'm playing with is like, would it be fun to have a collaborator on that project? Maybe, I don't know. But of course, there's no rush, so it's also kind of fine if I don't spend time on it right now. That's also cool.
Yeah, awesome. Switching gears a little bit. Into some of your open source work. I think the first library of yours that I was exposed to was Bulk. Maybe something else before that, but that one, I was using it. I think the backend was Bokeh at the time, which I think yeah.
It still is.
Oh, it still is? Okay. Yeah. And then you also have Embetter, Human Learn, What Lies, Doubt Lab. Those are the ones that I'm most familiar with. I know there's about another 2 dozen or 3 dozen
small
more.
Dozen at this point.
When do you decide like this project deserves an open source library?
I mean,
like when you think it's a tool, yeah.
So
you can speak. Yes, you can speak to it.
It helps a bit to maybe explain how the open source thing kind of got started. So my first open source project that I kind of put on PyPI was this thing called evol, which was just basically like a DSL for evolutionary programming. I made it with a colleague of mine. It was a very cute idea, and I just wanted to have my own little library. So I was like looking for a problem. And then I just find out that like, if I have like these kind, like I have a population object and an evolution object, and those two can interact in nice ways. It's super easy to make genetic algorithms. All right, cool library. Did a bunch of talks on that. But then at some point, I taught myself how to make, Python packages, and then I was a consultant, and I started noticing that at different clients, I would be writing the same scikit-learn components. So then I kind of figured, I got to have a library with these components that I keep reusing. And that's how scikit-lego came to be, and that's how I familiarized myself with the scikit-learn ecosystem. And then, I started working at Rasa, and there, we do lots of benchmarks on sentence classification, because Rasa builds chatbots, and when you're building chatbots, sentence comes in, and we need to figure out the intent. Okay, so I wrote a bunch of benchmarking tools because that's what I needed, and some of those can be open sourced. What Lies was an example of that, because I wanted to have a library where very quickly I could just have many non-English embeddings and see if they were better. And then it turned out that there's a whole non-English community around Rasa who was super interested in that. So I was able to build some Rasa plugins to just support all these non-English tools. And, then at some point I started maintaining my own libraries. And then I noticed that I need some unit tests for my docs, because I don't want my docs to break. So I made a couple of tools to help me do that. Make test docs. That's like one of these tools. I noticed that the tests over at Rasa were running super slow. So I made a PyTest duration insights thing so I could figure out which tests were slowest. And you can kind of see how all these things kind of accumulate, but it's always because I'm just scratching another itch. And my preferred way of operating is just to do that in public. And of course, there are tools that I cannot do in public. I work at a company. Some tools are private. That's fine. But most of the time, it's just that I've encountered a problem, and I just want to be able to solve it again later with very low effort. And because I've made packages before, it's just super easy to repeat. And that's also how DoubtLab happened. And it's also how embetter happened, and honestly, also how bulk happened. It's just that at some point, I figured, I need this for my work. It's nice to have around, so let's just package it and go. Build in public, and that works very well for me. That's the main story there, basically.
Yeah, very cool. And it's a great story. It seems like, building one tool, you build up certain skills, and then one thing kind of leads to another, and then it's not such a big deal when I guess you have like 36 amazing tools to add that 37th tool.
So yes, but I do want to maybe make one comment, because I do think that in general, like if I look at the companies that I've visited, back when I was a consultant, I do think not enough people make their own Python packages. Like, for example, imagine that you have like just a pandas query that has to deal with time series or something that is working on a very specific database. Okay, then the function that reads out the data from the database probably can be a function that needs to be reused. And I don't know, maybe you have to add sessions, or maybe you have a very specific machine learning model that you want to reuse. And for all of these like utilities, you don't want them to live in a notebook. You just want them to live in a Python package. And I have seen that not enough people make their own internal tools, which I do think is a shame. And I will say that, I was around a couple of mature colleagues at the time. Like, we would write our own Python tools internally. And because we were having that habit, it was also quite easy for me to make one that was just public. So like in general, this is like advice I might have for like a more general crowd. You can make Python packages more often than you might think. So like just build one, even if it's like for your own little helper functions in pandas that you like to use. That's a totally legitimate use case.
Yeah. To dive into, I guess, the one that I've used the most, bulk. Can you talk about bulk? I guess go through sort of like the pipeline and the requirements for it. What are the mechanisms at play?
Yeah, so it might be fun to also explain how that library accidentally happened. So I had a library called Human Learn. And so I had this one library called Human Learn. And the whole thing with Human Learn is that you can say, there's a couple of really cool features, but just as a human, you can now make scikit-learn models without knowing anything about machine learning. So one thing you can do is turn a Python function into a scikit-learn compatible component. That's kind of useful, because you can grid search over the kwargs and all that. However, one thing I thought was kind of cool too is like usually you see a plot, right, of like some blue dots there, some yellow dots there, some red ones there, and people say, this is what we need machine learning for, and an algorithm dissects them. But then I figured, you can also just draw a circle around the green dots and the circle around the blue ones, and just translate that circle into a scikit-learn model. So that's like a feature of Human Learn. In Human Learn, we have bokeh components that can do that from a notebook. And while I was working on that, I was also working on What Lies over at Rasa for all of these word embeddings. And then at some point it started dawning on me that when you take these word embeddings and when you pass them through UMAP, you kind of get these clusters. And then I kind of figured, I just kind of want to select them. Oh, hang on, I've got this tool called Human Learn that just does that. And so I just, within like an hour, I had that working on in a notebook. And then I showed it to a bunch of colleagues, and they all kind of went, "This is super useful, Vinny. Well done." So that was a notebook that got shared around a lot. And then, after a while, I no longer work at Rasa, but then I started working at this company called Explosion. We have a annotation tool. And then I kind of felt like doing the bulk trick again, but I didn't feel like using that in a notebook. So I just turned that into a little web app. That you can run locally, and it's like one of the pre-processing steps I like to use. Like the thing you do before you start annotating in Prodigy is you just take your data, you embed it into a 2D plot using UMap, and then you typically see clusters, and you just try to explore that space, make a selection, and that's it. It's a very nice way to do bulk labeling because clusters tend to appear from these embeddings, and that's basically the whole trick. These bulk labeling techniques, they kind of work, but they're not perfect, but they seem pragmatic enough for me to just go ahead and get started within an hour. And that's kind of the power of it. Stuff that used to take me, like, if getting started used to take me 6 hours, it now takes me only 1 hour. And it's a trick that only works for getting started, but I get started a lot on a lot of new data sets. So for me, it just totally solves a problem. Bulk is also one of these projects where I would love to have more time to, fix some of the rough edges, but it is like a little hack that totally works, and I love using it. And there seems to be like a little crowd of people who seem very appreciative of that tool as well, especially because it does text but also images. That's like out of the box, it just does that.
Very cool. Yeah, I used bulk when it was in a notebook. I know I reached out to you. You were very generous with your time, trying to help me running it in different environments.
The first notebook was definitely buggy. That's definitely true. Yeah, I definitely remember that.
You still got this.
Well, I mean, so I
still got the trick done.
Yeah, well, the thing also, back at Rasa, I would also make a habit of making these videos. So, like, bulk had like a YouTube video attached as well, which is how a lot of people found out about it. And I think there's this one repository that just happens to have that notebook, which is still like getting GitHub stars these days. But I recommend people just use the command line thing now because it's just less distraction and just a bit more stable, I would say.
Yeah. And then interestingly for me, like as I was moving a lot of my work outside of notebooks and things like that, I came across bulk again, and now I'm using more of the web app. I love both of them. They're great tools, and yeah, you make a good point. Sometimes lowering the barrier to get started on a problem is just so important, because then you start to get the ball rolling, you start to get some thoughts going, and you can make some meaningful progress. What I like about it is it like you start building some intuition, right, by like exploring the data, and you start to think like, oh, okay, these could be some potential categories. So yeah, I mean, I think it's a great tool.
There's definitely a human in the loop is learning as well aspect of it that I also think is really useful, especially when they dump a new data set on you. I mean, yeah, you can start throwing it into an algorithm and that's, whatever, but genuinely like understanding what's in the data set typically is the thing that takes the most time. And I do think it's nice that like as a side effect of bulk, you are at least exposing yourself to these clusters, and that on its own seems quite useful. One of the things I am working on, by the way, is that right now you can do bulk labeling on like sentences and images. I do want to start doing that for phrases as well, for like substrings in text. So right now I can embed the entire sentence, but what I want to move towards is that I'm also able to say, take every noun phrase in that sentence and make a small little point for that. Because that way, if you're interested in doing named entity recognition or something like that, we can also do bulk labeling for you. Especially things like video games, there might be abbreviations, and
right.
I don't know, Star Wars are 2 tokens. Be nice if we can turn it into a single phrase. And over at our company, Explosion, we have lots of tricks that totally solve all of this. It's just that I need to have an afternoon to make that work inside of bulk. But that's like stuff that is on the roadmap. Like I am definitely interested in solving some of those problems as well.
Yeah. So I know I've noticed going through some of your work, a lot of it is focused on creating high quality data sets. But something before that is actually, understanding the problem. And I watched one of your PyData talks basically about rephrasing the problem. And you gave an incredible metaphor or just an example about a problem where someone's looking for beans, beef, and bread.
Yeah.
Can you talk about that one?
So this was not my tale. Like, I actually met the person who works at the World Food Program doing operations research. And one of the problems that they had was, there's hunger in the world. And sometimes a village who with hunger says, we need more beans, or we need more chicken, or there's demand, so to say, for certain products. And then part of what the World Food Organization tries to do is try to source those foodstuffs cheaply. And then part of the cost picture here is the logistics of it. So can we get the food on a truck, and how expensive is it to get the truck here? And sort of just the whole logistics of that stuff. And as this person was saying, they defined the problem the wrong way originally, because when a person says, I need beans, yes, they can say that, but it's not beans that they need, it's nutrients. And beans, they're high in fiber and high in protein. Okay, but there's other food like lentils that is also high in fiber and high in protein. And if we're fighting hunger, then we're not going to be very picky about whether or not we get beans or lentils. And maybe if we do that, we can get the foodstuff without needing a shipyard. We can just send the truck. And just by redefining that problem, I believe they got like a 5% cost reduction, which is a crazy high number for operation for a problem that people have already spent like years on trying to optimize. Getting a 5% cost reduction is like almost unheard of, but it was basically because they were solving the wrong problem. And my theory is, at least, that this is an anecdote of like a thing that happened to this one person for the World Food Program. But quite typically, this whole act of rephrasing is a very useful exercise that maybe not enough of us do. And to give an example of NLP, one of the things I sometimes see on like our support forum is, let's say they have a resume that they want to parse, and then they say, well, I want to have the start date and the end date, per job. So I want to have an algorithm that can detect the start date. And, you can build an algorithm that can detect the start date. That's fine. But if you rephrase the problem into, let's first find all the dates and then afterwards figure out which one is the start date and the end date, then the second problem becomes, well, the start date's probably first and the end date's probably after that. The whole problem just becomes a whole lot simpler if you just rephrase the problem into a two-step approach instead of considering it end-to-end. And there's lots of these opportunities, I think, that people forget about. To come back to Calmcode, I fear that partially some of the machine learning textbooks are to blame, because very few machine learning books actually tell you that you can choose to ignore half the data if it makes more sense. You can choose to just solve a different problem if that's easier to solve. But that's like not a mode of thinking I seem to see, especially with new graduates, which is a bit of a shame. But that World Food Program story, I have to trust the person on stage who told it to me, but that definitely happened. Like, the World Food Program found a way to reduce cost of transportation by 5% just by rephrasing a mathematical problem. That's definitely something that happens in real life.
Yeah, and I mean, doing something at that scale, any sort of reduction, a 5% reduction is math, like that would be massive. My favorite quote from that presentation, you said, it wasn't the algorithm that saved the day, rather an understanding of the world. A better algorithm will yield a worse outcome if it is used on the wrong problem. Really like that one.
Oh, happy to hear it. No, so there's more anecdotes in that story, but if people are interested in this, by the way, there is a operations researcher called, I believe, John Ackoff. And he wrote this one paper about I think the title was "The Future of Operations Research is Past," which he wrote in the 80s. But he basically just outlines why operations research algorithms can fail, and it's reasons related to this anecdote. The reason why I want to bring this up is because some of those arguments work for data science too. It's an article from the 80s, but it's everyone should read it. The future of operations research is past, and I wrote a similar article called "The Future of Data Science is Past," just by repeating a couple of those arguments. But people often forget that the algorithm is usually just a cog in the system, and we're interested in building a better system, not a better cog. So if you're building a better cog but it doesn't fit the rest, it's not a better cog because you don't get a better system. Another thing that Ackoff does very well in his books, he basically explains a lot of these systems theories things. And one quote there that I can recommend people think more about is maybe instead of making, let's say, a better cog, instead of thinking hey, maybe there's one part of the system that we can optimize, maybe instead try to see if you can make the communication between two parts better. Because that's like, if you think about it from a systems perspective, by doing that, you're optimizing two things, and also you're gaining clarity. So that's always good. And it's definitely this sort of, let's think about a problem by reducing it down to a single number and not consider anything else. Like, that's usually like a rabbit hole where people lose themselves in as well in data science, I think.
It's super interesting because I think that there are a lot of times when people approach problems, sometimes they focus on sort of the different modules, and they have this modular way of thinking about things, and they go, oh, if I make this one thing the best that it can be, then, the whole system will be better. And in some cases it will make, a great improvement, but other times it's very important that the supporting system, how does it integrate? It reminds me of like, you have to have good integration tests, and you need to make sure that everything fits into the system properly.
I think so. There was this, to give an anecdote here. Like, I remember. So the former CEO of bol.com wrote this in his autobiography. So bol.com is like the Dutch Amazon. Amazon's not that big here. Bol.com is basically Amazon, but blue and Dutch. That's kind of the thing we have here. But they hired their first data scientist at some point, and this book has like a chapter on that. Like, what happened when we got our first data scientist? And in the book, the first data scientist portrayed as kind of an arrogant kind of a person, who's always complaining like, all these humans, they're not as good as my algorithm. And then, like, one of the things that he does is he figures out that there's an optimal time to tweet about new video games that come out on their social channels and etc. So that's like a thing he did. In Holland, we have this thing called Remembrance Day. And I believe it's 7 o'clock, could be 8, but during Remembrance Day, we remember the Second World War, and basically the entire country goes for a 2-minute silence. You might have seen some of the photos where, like, people on their bikes delivering pizzas would, step off the bike, just stand still for 2 minutes. It's a thing that people take quite serious. So 7 o'clock on Remembrance Day will be a very bad time to tweet about the new Call of Duty shooting game where you can shoot a bunch of people. And it would be especially bad if you would tweet that you're super excited about the prospect of shooting people during Remembrance Day. But that's exactly what happened, because his algorithm determined that 7 o'clock was the optimal time to start tweeting about this sort of thing. And there's so many of these stories, right? And like, on their own, on paper, I cannot necessarily blame the data scientist for doing, his or her work, but this is like the systems thing. They're like, the group 1 has a concern that something might go wrong. Group 2 does not. If you just get them talking to each other, then usually the world's a better place. That's a theme, I would say. Yeah.
That's the old, when you get the answer to your problem and you have to say, like, does this make sense? Yes. I think that's that's sometimes a little step that a lot of people skip over, and it's extremely important.
I mean, I do want to maybe acknowledge it's also hard, right? I mean, I think calling.fit.predict the easy bit. It's all the stuff around that's like way trickier, especially when you consider themes of fairness, like all the things that can go wrong. Like, can we really know that up front? I don't know if you always can. To give one shout out though, there is this project, I think it's called Dion, if I'm not mistaken, the Dion checklist. There is a Calmcode course, it's called Dion, but Dion is a data science checklist. So just a bunch of stuff that has gone wrong at different companies where there's newspaper articles like explaining how bad the situation became. They just have a checklist of stuff that, like, hey, check for this before you push live because stuff might go wrong. And for every item on that checklist, they also have like 2 newspaper articles of like stuff that happened in the past. So you, as the data scientist, can go up to your boss and say, I want to de-risk this because this actually went wrong. Right. And it's a really cool project just because they actually did like the proper collecting of anecdotes, which I think is a powerful act in this day and age.
Yeah, 100%. Having a story connected to anything in data science is always valuable. To zoom out and just, I guess, to talk about machine learning in general, it's a question I like to ask. What's an important question that you believe remains unanswered in machine learning?
I mean, okay, so I was drinking at a PyData after party. And some, a couple of people came up to me, and these were people I would consider relatively senior. Like they knew their stuff, and they asked me to predict the future of machine learning. And I kind of felt like making a joke because you're at the bar. I wasn't really inclined to go super into that, but as a joke, I figured I would say, you know what? I think the future of data science, people are going to really realize just the sheer amount of nonsense that's in our field, and we should maybe just stop altogether. But then I started thinking about it more, and I will say there is some truth to that. Actually, I do kind of worry that maybe a lot of the stuff that we're doing is more like, oh, can we, do the hype thing instead of are we sure that we understand the problem? So, what's missing in machine learning? Well, maybe we're doing too much of it. It's kind of also like a feeling that I have. And of course, there's a place in machine learning in the future. Like it's definitely going to happen, but it doesn't have to be everything. Like that's kind of more the thing that I'm afraid of. I forget the author, which I'm a bit bummed out about now, but there's an author who writes a book about artificial weirdness, just like all the weird gunk that artificial intelligence can produce. And the book is called "You Look Like a Thing and I Love You," and that's because she trained the author. I should read the look. "You Look Like a Thing and I Love You" by Janelle Shane. But have a read. The book starts by saying, I have all of these Tinder texts, and I want to have an algorithm figure out the best Tinder text to send. And the algorithm came with, "You look like a thing and I love you," which is kind of a hilariously brilliant thing, but it's not the thing you should send, I think, on Tinder. But the book is full of these examples where you kind of have to be careful that artificial stupidity is not sort of happening at the same time as well, right? There's plenty of examples where that happens. Like the Call of Duty thing is just one example. So I don't know. Like I'm a little bit. I find myself to be kind of the grumpy old guy, sort of yells at clouds. Kind of sure, machine learning has a place, but can we do without it first? Like I first tried a simple thing, because that's something that people seem to forget to do, and that's like I think a more pressing concern, personally.
In a similar vein, with the, everything that's going on in natural language processing right now with generative models and ChatGPT, how do you view the gap between the hype and the reality? I'm excited to get the old grumpy guy's perspective on this.
So I am actually professionally toying with this stuff. So, and you can actually, if you have a look, the Explosion repository now, OpenAI Prodigy recipes, I think. Yeah, that's the name of the repository. So we are experimenting a little bit with like, hey, can ChatGPT-3 just say, here's a sentence, detect all the dates, just so we can like pre-highlight that in our Prodigy interface. It's like something we are exploring right now. And it turns out it's actually really good at some of these examples. And it's really bad at others. We don't fully understand why yet. But I will acknowledge here, like, hey, that can be quite useful. If that's something that you can use to get better training data quicker because the annotation is just a lot easier, just saying yes or no is quicker than sort of highlighting every single item in the user interface. That seems totally fine. What I think is a bit more of a concern, though, is that people sort of say, it's magic. That's how this works. It's magic. Like, it's not magic. It's it's kind of like, to some extent, it's kind of like the Markov chain thing where it just predicts the next word. And you can kind of imagine that if you just give that enough text and enough compute power, you might be able to sort of have it generate very plausible text that you might find on the internet. Then you can ask questions like, is this generalizing or is it just remembering? And, those are all fair questions, but it's not intelligence just yet. It's not real reasoning. And I have plenty of silly examples that demonstrate that it's not actual intelligence that's what's happening under the hood. That said, again, as long as there's a human in the loop and it proves to be useful and productive, then I think it's fine. But again, that's when I'm wearing the lens of, hey, there are professional interests. There are, of course, also like harmful vectors that I do think need to be taken into consideration as well. You can definitely send more mass emails in bulk and maybe have more Twitter bots and all of those things that I'm not particularly fond of.
Right.
So anyway, like that's one aspect. Like another thing I do also maybe want to like highlight, because I also tried the Midjourney thing. Like I tried to generate Magic the Gathering cards. So I thought like
I've seen they're pretty funny.
So I thought at some point it would be kind of funny to say like, hey, let's make Magic the Gathering cards of orcs in the office. Like you would have like an orc warlord product manager and like an orc venture capitalist and like an orc TED keynote speaker. And you know, like immediately this idea is pretty funny because if you think about The Office, you kind of think like a dull gray suit. And if you think of an orc, you think like World of Warcraft, Epic Warmonger, etc. And so, you know, that was pretty funny. But then the next question is, can we actually generate really funny pictures? And that turned out to be somewhat hard. So I have this one picture of like an orc paladin, like totally covered in iron, basically, like behind the computer. And you do kind of go like, okay, like data engineer, kind of that's kind of funny already. But I wanted this orc to be a data analytics engineer because they are talking about data lakes. And then I thought the funny thing would be heavy ironclad orc, but like little yellow snorkel comes out of like the helmet. Like that would just be the funniest thing. And for the life of me, I could not get it to generate a yellow snorkel. And you start thinking about, like, why might that be? And then you also think, like, well, Vincent, you're already kind of stretching it to have, like, these World of Warcraft Dungeons & Dragons styles in an office. Like, the fact that those two styles are even compatible is already kind of a stretch, let alone that you also generate some sort of weird snorkel from it, right? So if people consider these tools like magic, the best advice that I do have is try to come up with, like, a kind of an awkward, weird task that tries to touch where the edges are of where such algorithms are comfortable, and that's usually going to give you examples that can maybe help you consider that it's not really magic what's happening. There's just this, it's trying to remember, it's trying to sort of generate stuff that it's seen before. And there's plenty of edge case examples where this sort of stuff is just, you look like a thing and I love you. Read that book. It has really compelling examples, and the style of the book is lovely too. I can highly recommend it.
Thank you. Yeah, I will check it out. Yeah, I think generative models are super interesting because unlike predictive models, you know, where you're doing like text categorization, where you can sort of know your best if it's correct or not. There is like a ground truth. With generative models where you're doing something like you want to create an orc that's wearing a snorkel, you know, how do you know that it's correct, right? Like it's not so clear cut.
How many labels of unrelated photos do you need to actually generate that, right? No, but also here is why I also like to think like part of the solution here is obviously like user interface as well. Like I think having text as an input is, you know, there's amazing things you can do with that. But in this case, you also, okay, we're almost there. I just want to select the region around the helmet where a yellow snorkel needs to appear. Something like that is going to happen at some point, and that's going to make these systems better. And then I can move on to enterprise elves and figure out some other edge case, right? And that will kind of be a continuous thing. But yeah, like I will say, like in general, like because you mentioned ground truth, right? Ground truth is tricky too. And this is also where a lot of artificial stupidity kind of comes from. And like my personal gripe with that, I mean, so consider like image classification, like the famous cat-dog thing. Like, is this a picture of a dog or is this a picture of a cat? Standard classification would say, okay, this is a binary task. But then you kind of go, well, but we can have photos with no cats or dogs. So, okay, we need 3 classes. Okay, what do you do with photos that have both a cat and a dog? Oh, yeah, okay, that can happen too. Right, okay. Reality's more complex. Okay, what do we do then? Okay, well, maybe we have to say, is there a dog in the photo? Yes, no. And is there a cat in the photo? Yes, no. Maybe those should just be 2 binary classifications. Maybe that'd be more sensible. Okay, what do you do when there's 4 dogs in the photo? Like, and again, like, the more and more you start thinking about it, you also kind of realize, like even the well-defined text classification thing doesn't always mix well with reality either. And even if you have ground truth labels, you kind of got to wonder, well, the ground truth labels maybe don't mix with reality either if it's defined as a classification task, because a sentence can be about more than one topic, and the photo can be about more than one thing as well. So again, like taking a step back and just really wondering, well, some of these things can be details as long as we understand the problem, but maybe we should focus on that then.
Yeah.
Maybe it doesn't. So maybe it doesn't. Maybe we should skip hyperparameter tuning and only worry about like, do we really understand the problem?
Yeah. Yeah. That's a really good point. I think that, when you're approaching a problem, you jump to a solution. If you're doing something like text classification, okay, I'm going to create a multi-class text classifier. Well, it turns out that it's never really quite that simple, right? It's really multi-label. Should I use a hierarchy? Should I do this? Should I do that? And, getting a better understanding of the problem always, helps you figure out so much more valuable than doing hyperparameter tuning on that original multi-class text classifier. To zoom out. Oh yeah.
Well, and like if people feel like,
continue.
Well, so the main thing, I do have like a little bit of advice. Like the general, I'm on the Prodigy forum and I help some SpaCy users with their problems. The most general advice that I do give people in this domain is consider that maybe the model can do one step, but your system can do 2 or 3 if need be. So definitely feel free to consider the 2-step system, where we have a couple of classifiers that detect a couple of properties, and then we have a rule-based system after that's going to say, okay, this combination of things, that seems interesting, let's go for that. People forget about the rule-based system that can be built on top of, and that's a bit of a miss. But it's also like 80% of the time that's also the fix. So do with this information what you will, dear audience, but I do think that there's a 2-step approach definitely does work in general.
I think that's really good advice, especially right now with all of the hype with deep learning. I think we're still in a world where, finding the right combination between machine learning models and heuristics sometimes, pretty basic heuristics often yields the best results. To move into the learning from machine learning portion of our talk, we'll start with this. Who are some people in the machine learning field that influence you?
I mean, I've had some really lovely direct colleagues that I still hang out with. So those, obviously. And then I guess back when I started, I was learning R, so Hadley Wickham was a person I definitely looked up to a lot, and I also met him on a couple of occasions, which is super cool. Like he did an advanced R course like 5 years ago, and I was his TA. It was like great experience. Got to meet the guy. So Catherine Jarmel is a person that also kind of comes to mind. She was one of the Kickstarters behind PyLadies, but she also has been like a great advocate for privacy and sort of fairness in machine learning and stuff. And she has reviewed my slides in the past for a couple of talks, and she's just great. She comes to mind. Vicky Boykes, I think, is like one of the funniest people that can't get, like, she deserves way more credit for shitposting, but she's great. Like the normconf thing was also like an amazing thing that she helped kickstart there. Like that was great. And then Brett Victor, I think, has the best talk I've ever seen that I will ever see. The Future of Programming by Brett Victor. That's like a thing I watch every year, basically. That's the most, like, the gobsmack, most inspirational thing I've ever seen. I won't tell you what the thing is about. Just watch it.
I'm looking forward to it.
And then I guess John Akoff. But the main thing with John Akoff was, like, I did this whole master's degree in operations research, and then, like, a professor was going to retire, and I was like one of the speakers at his party. And then at some point he goes, the reason I wanted you here is because you really remind me of John Akoff. Like, who is he? Like, who's this amazing guy? Just buy his book. And then you read his stuff, and it's like, Jesus Christ, he's like me in the 80s. So like, that was definitely also like a good source of inspiration. But to be honest, like, one thing I do want to maybe mention about this is, like, back when I was organizing a PyData, right? Like, you kind of think like, okay, who are good keynote speakers and who are good, like, invited speakers, etc. And my impression is that there's, like, the average Joe is pretty inspirational, but the average Joe doesn't, like, think that he or she should be on stage. And the best example of this is at PyData London, there was a normal talk by a guy who was building drones to find endangered species of orangutan in the rainforests of Borneo. And he had
Wow.
the small room, but his talk was amazing. So I figured, screw this, you're the keynote at Amsterdam. Like this is the most amazing thing I've ever heard. This is your hobby. So he was the keynote speaker the next year, and he was grateful and we had good fun. But like he didn't realize that was like definite keynote material. And similarly, I read this blog post once where this guy was trying to figure out which words are the most metal. And the way he did that was by training a huge Markov chain on metal lyrics and non-metal lyrics. And the conclusion of the blog post was the least metal word is cooperation, because it only appears in the corpus once. And you read this and you do kind of go like, this is amazing, because you're basically, you're applying the theory correctly on a pretty, humorously silly problem, maybe, but there's passion here. And the guy, when I did approach him, like, you really need to apply for PyData. Like, I would love to, like, I don't have to review your thing. Like, I think you're going to be in. And it just hadn't occurred to him that this was something he could do. And I like to think that there are so many more people who suffer from this, that they might have like a really grand, amazing, inspirational moment, but don't consider that they're able to share that. And of course, some people are like properly introverts, which is also just fine. But one lesson I have learned at PyData is that the inspiration can really come from surprising angles that you don't expect. So don't focus too much on the big names. That's also a thing.
Yeah. Those are the best, well, not the best, one of the best types of people that are very humble and, they do such a good job with their work, and just, you can tell how much they care about what they do and how much, I don't know if pride's the right word, but they take their work very seriously. So they care.
They care. And there's definitely like, you can be the smartest person, but if you don't care about your topic, it's not going to be a great talk. And let's say that, maybe you've cut a few corners, but you calculated the optimal Pokemon. I don't know, like something like that. It can still be a great talk. And again, more people should do it. If people are interested in doing more blogs and talks, by the way, consider lightning talks and very short blog posts called Today I Learned. The world definitely needs more of that. And I'm happy to see PyData Amsterdam, the meetup. Once a year, they kind of do like the lightning talk meetup, where just I think like 10 people give a 5-minute presentation. Those meetups tend to be amazing. To any PyData organizers listening, feel free to steal this idea. Those meetups are always fun.
Very cool. So you've given a lot of advice so far, but I want to ask, what's one piece of advice or something that's stuck out that you've received that's helped you in your machine learning or career journey?
I mean, I got very early on in my career, my former CTO that I still hang out with gave me pretty good career advice when I was 23. And he basically said, well, be careful of getting a raise. Because if your job starts earning a lot of money, but it's kind of getting boring, then the money might be a reason that you're going to stick around. And that's a dangerous thing early in your career. Because, especially early in your career, maybe you got to figure out what you like in life. And maybe you got to figure out what makes you tick. And if you're going to hyper-focus on the money, it's kind of like hyper-focusing on a metric. You're gonna over-optimize for something that might not matter as much. So that was like pretty cool advice, I would say. Kind of on the meta side. But I do think, in general, I have been able to sort of apply that quite well. And again, privilege speaking here, right? But like, I have been able to apply that, so that's been cool. And I don't know, like, the main, I guess the main thing I guess that's been kind of a weird anecdote, but it's surprisingly inspirational as well. So I have a lot of friends who do nothing in data science. And I love that. I'm Nerdy Vincent, and when I drink beer with them, they say, "Stop being Nerdy Vincent. You're amongst normal people again. Like you can just talk about like life now." And one of these like buddies of mine, like I live in a neighborhood where like all of your neighbors basically, and it's like it's sort of still kind of a middle classy neighborhood thing. Like it's changing because gentrification, but like we all know each other. So there's a guy in my street, and he's a painter. And when it's nice weather, he puts a crate of beer on his bench outside of his house, and the whole street just sort of goes for a pint, basically. It's the cutest thing, cutest neighborhood ever. But the thing with him is he recently became an independent contractor as a painter, which also meant that he bought his first laptop ever. And he's 42. And like he needs help, not just with his website, but like getting Word started. Like his entire life, the main computer that he had was his phone, and he's been fine. But he finds the computer terribly, terribly complex. And to be honest, I find that just such a refreshing thing. To also be reminded of the fact that like the way that I experience computers doesn't necessarily have to be normal. Like that's like a very useful reminder, I think.
Right.
So like the best inspiration in that sense, like just maybe don't be in machine learning all the time is my advice. Also because, you know, especially if you're making machine learning for apps that the average person uses, so to say, it really helps to remember that they really don't care about your algorithm. They just don't. Like they really, really don't.
Right.
And I don't know, like you can be. I have found myself to be stuck in a machine learning bubble at times, and I just find it very refreshing to sort of. I used to do this at like consultancy gigs as well. Like at some point I was making an app that the truckers would have to use, like logistics stuff. And at some point I would just hang out at the smokers corner where all the truckers would hang out just to sort of understand what kind of people they were. And also just to understand what they found frustrating about the app and that kind of like doing more of that really, like being more of a human in the loop and like focus on the human thing is I guess what I'm trying to do more of and what I find very inspirational, I suppose.
Yeah, I really like that. One more advice question. For somebody who is just starting out in the field, let's say that they just got hired as a junior data scientist, or they're thinking about starting in data science, what would your advice be to them?
Okay, so step one, I gave a talk on this topic at NormConf. So there's a talk titled Group Advice Statements That Save the Day. This talk is precisely designed for you. Having said that, I mean, I'm a really bad person to give career advice because looking back, I just thought that a large chunk of where I am today is due to luck, and that's something that's kind of hard to optimize for. What I do think is, in general, perhaps useful is maybe have your own blog where you just share things that you learned today. So just like Calmcode is still kind of my snippets library in a way, practically, your blog can be the same for you. And in general, I have found that these Today I Learned snippets, if you're able to write 2 a month, let's say, and they take maybe half an hour per thing instead of like a big blog post that takes hours. This thing shouldn't take more than like tens of minutes, let's say. But you do it for a year and you've got a blog with 24 posts. And if you're learning and you're able to share knowledge that way, people are going to sort of acknowledge that like you do have a bit of a resume there that can demonstrate that you're learning stuff. So that seems like a pretty easy thing to do if you want to get something of an online presence with low effort. So that's something I recommend. And I guess like the other advice is I do think it's a bit of a shame now that, you know, the hiring market and all that, if you are like a super junior just getting started, I do want to acknowledge it's kind of hard. But one thing that you can do to make it maybe slightly easier for yourself is to consider that you don't have to know everything in order to get the job. You might also be able to get a related job. So some advice that I have given friends of mine who wanted to sort of get into this data science field is I advise them, well, it's a little bit easier maybe to learn R than it is to learn Python, and it's maybe a little bit easier to just be an analyst for a year or two. And all the skills you learn while being an analyst are going to be super useful if you want to become a data science person later. So if it's easier and you get paid to learn, don't optimize for a title. Just optimize for like the stuff that you learn while on the job. That it seems easier. And there's nothing wrong with being a good analyst. Maybe we need more good analysts than we do good data scientists as well, right? Maybe we need more group by statements that save the day. Hint: watch the talk. But I do think like there's a little bit of snobbery when it comes to like job titles. Like, oh, I'm the super senior staff mega engineer. Like, sure, but if you're just a really decent analyst, we need more very decent analysts. That's also fine. Like, go for that.
Yeah, that's definitely good advice. And now the question that we've all been waiting for. What has a career in machine learning taught you about life?
Some problems solve themselves when you ignore them. Like seriously, like I've been in so many of these situations where the problem got solved by just ignoring the machine learning bit that you kind of start to wonder, well, maybe some problems just solve themselves if you ignore them. And I have noticed in a few instances this is just kind of the case. like, especially when you have a child, like, you do kind of learn that, like, there's some stuff that you can over optimize for as well. And like, oh, the baby's not sleeping well, that problem will sort itself out at some point. It's not necessarily it's not like influence from my end is going to make like a very significant impact there. And I guess the same thing with machine learning. Like, there's some stuff that you can control, some stuff that you can't. Just make sure that you understand what you can and cannot control, and then move on from there. And again, like, I'm kind of a mixed bag when it comes to the whole machine learning thing. Part of my opinion is it's a super useful tool, and like, we need more good people doing machine learning. But at the same time, it's like a gross bucket of hype that we really want to have less of. And my day-to-day sort of job is to sort of deal with both of these feelings. I hope this answered the question in some way, but that's kind of where I'm at. That's kind of where I'm at.
Some problems,
and also like try to do it calmly, I guess. To make the final pun is also something I might recommend.
There you go. I think that some problems over time do resolve themselves, and also I like the first rule of machine learning is: do you really need to use machine learning? Yeah, it has been. I agree. And one thing I really appreciate, to maybe brag about the employer a bit, one thing I really like about SpaCy is you don't have to use the machine learning bits. You can also just use the non-machine learning bits in SpaCy, and they are also performant, fast, and super useful. There are also machine learning packages that allow you to do some rule-based stuff. And if you're doing NLP, like, this is really why I love using SpaCy. You don't have to use statistical stuff all the time. The rule-based engines are great too. End of pitch. Yeah, I've been a huge fan of SpaCy. Trying to think for how long. For a while now, at least 3 years, probably more. It's helped me solve lots of problems, from named entity recognition, text classification, cool ways of doing matching. All of that.
For me,
it has been. Oh yes.
Well, so if I can give one final pitch. So there's a lot of talk about data-centric AI these days, but the reason why I started like getting interested in what these explosion people were doing back in the day is there's a blog post from 2017 called "Supervised Learning is Great, It's Data Collection That's Broken." They were doing data-centric stuff in 2017, but that's one of the best blog posts I've ever read. So they talk about data quality, and like one of the best quotes ever is, "Don't expect great data if you're boring the shit out of underpaid people," because Mechanical Turk is still like the way people go sometimes. Read that blog post. I will give you a link for the show notes. Like, that's also like a highly inspirational thing people should read.
Awesome.
End of speech.
Thank you so much. It has been such a pleasure to talk with you. You've given me tons of great resources. Putting together the show notes for this one is definitely going to be a good time. If there are some places that you would want listeners maybe to learn more about you, what would those places be?
So I'm on Twitter and Fostodon these days. But like, the main thing I cannot announce anything just yet. It's just that I work at Explosion and I can see the stuff that's in the pipeline. So I'm working on very cool stuff, and there's definitely going to be announcements of like super cool stuff all of my other colleagues are working on. Just follow Explosion. There's a bunch of really cool stuff in the pipeline is the main thing I will say. And if you do that, then you also at some point will hear about some of the stuff that I'm working on.
Awesome. Thank you so much, Vincent. It has truly been a pleasure.
Likewise.
Thank you for listening to Learning from Machine Learning. This episode was packed with gems from Vincent Warmerdam, the creator of Calmcode and currently a machine learning engineer at Explosion, the company behind SpaCy. Be sure to check out the show notes to learn more about this podcast and some of the topics discussed. Talk soon, and keep on learning.